Good afternoon, ladies and gentlemen. Discovering the tropical gravity wave, but why Atacama? The expeditions to Argentina being definitely closed due to corruption and insecurity, and as I had a STEM S10 from a Chilean friend, I decided to go explore the volcanoes of Atacama, whose cumulus clouds are already at 8,000 meters at 9 o'clock in the morning, as seen in this photo. An American expedition organized in 1986 crossed the Atacama Desert but did not flew over the volcanoes. Unfortunately, we must have become quickly disillusioned because we had not taken into account the Bolivian winter, which causes the whole system to degenerate at the beginning of the afternoon and becomes unflyable. Here is the photo of the Licancabur at 1 p.m. The Bolivian winter phenomenon is well known to local populations. It brings rain and snow even in summer. This is a return from the east of an Amazonian air mass between the ground and about 8,000 meters, humid and unstable as shown in the sounding, which is a reforecast sounding made by SkySight. So as you can see, we have a good instability in the morning with cumulus base at 8,000 meters, and then as soon as the temperature rises in the afternoon, the whole system goes to 9,000 meters and degenerates. And you can see the stratified flow with westerly flow in the morning and easterly flow from 500 millibars to approximately 7,000 meters, then back west. But this creates the Bolivian winter. The November 2019 expedition will be based in Calama, a horrible industrial city located 100 kilometers from the volcano, but whose airport is secure, which was necessary in this time of social revolution. Remember that. The wind rose at this airport in November shows a very simple system with a descending breeze, this one, every morning, and an uphill thermal breeze every afternoon here. As the ascending breeze is stronger than the descending one, I thought there might be a geostrophic wind component sometime, so maybe some dynamic phenomena. This is the flying area. We had a Chilean clearance for level 240 in this area, but no clearance from either Bolivia, which was simply prohibited, and Argentina, which is here. The discoveries that I'm explaining to you were made in the year following the expedition because we had no means or assistance to carry out this type of analysis. In particular, this cross-section of the between the ocean here and the volcanoes passing through Calama here, our base, will be very useful to understand the phenomena. The air mass coming from the Pacific here is lifted from 0 to 4,500 meters on the Bolivian Altiplano, the Puna they call it, in only 250 kilometers. So if we admit that the level of a tropical tropopause here is approximately 14,000 meters, then the section of passage of the air mass is reduced by 40% his to that when arriving on the Altiplano, and therefore undergoes a compression far from being negligible. In addition, the Atacama Desert, which stretches over 200 kilometers, this one, happens to be the driest desert in the world, very hot, and will strongly condition the air mass. We see in this diagram the journey that we had to make every day from Calama to the volcano, 100 kilometers, climbing from 2,200 meters to 4,500 meters, which was the ceiling of our old Volkswagen atmospheric engine. San Pedro de Atacama airfield, you can see here, although unsecure and in poor condition, was for us the key of the success, because it's located only 30 kilometers from the pass, this one, connecting the Altiplano to San Pedro, located at 4,500 meters. So the photo gives you an idea of the landscape. The volcan Sairecabur was for us the key to all flights, both outward and return, allow us to climb to at least 6,000 meters every day to return to Calama with an L/D of minimum 30. Our first contact with conventional southwest breeze 10-50 knot was not sufficient to produce lift. This is the trace of the first wave flight, so engine to here, on the slopes of the Sairecabur, which do not work. Then we crossed downwind to Bolivia and surged from the jump while keeping the engine running. In reality, the very weak lift found at 5,000 meters here becomes very good, and we can leave at 6,000-7,000 meters here. We will have to apply this technique to each flight and also for the return flight, because the 100 kilometers from here to Calama are simply totally unlandable and uncrashable. So still using the light southwest breeze, I was able to exploit the downwind convergence lift of a conical volcano, as explained in my book. So as you see, this is the afternoon breeze, this is the Licancabur, completely conical. I could not work the ridge, so on the downwind, on the lee side, I could work the convergence lift up to 7,000 or 6,000 meters. Well, strangely, this convergence lift did not allow us to climb higher than the summit of the volcano, but it was sufficient. This is Licancabur. We could reach approximately 6,000 meters. And it was the same. Every conical volcano to the south was working in the same way. Here you can see the oasis of San Pedro. The wind was 10 to 15 knots west, and this is the trace of a flight where you can see that we could stop at every volcano and it worked. So I had to believe my book. Okay, it became clear that the dynamic system worked well as soon as the geostrophic wind was aligned with the thermal breeze. And after 3 weeks, we started to be very attentive to weak signals to detect the west flow, in particular the jet streams far away to the south. And the geopotential 500 hectopascal was not usable because it is the ground altitude. So you can see here the classic map is red, and you don't see any flow here. And this is the Tropic of Capricorn, and we were flying this area. The public map showing the jet stream was very useful, since even 500 kilometers to the south, we could locate the jet stream, and the jet stream was influencing very strongly the waves in our flying area. You can see here. Just for recording, this is Patagonia, where we were flying the record flights previous years. The same applies to the American charts of significant weather. This is public, so we were flying here, and we could observe this jet stream and we could anticipate a good day. Then let's go to what we call retrospective forecasting or reforecasting. Since I had no time and no tools to fully understand the forecast and what was happening, Matthew Scudder of SkySight and Ezio Sarti of Meteorwind agreed to rebuild the GFS and WRF database for the 6 most interesting days and to run their software almost 1 year after the flights. Ezio Sarti is also a WMO certified meteorologist and has helped us a lot with technical analysis. So this is the example of a reforecasting made by Ezio Sarti for the day of November 26, which was the most beautiful day of the expeditions. The white spot at the top of the photo is the Salar de Uyuni in Bolivia, very famous. And you can see the waves, which in fact was a primary hydraulic jump. So they come back to the first day of operation of the wave, November, 7th of November. This is the SkySight reforecasting, which doesn't show anything particular, but confirms the still westerly wind at all altitudes. You see, we are all west, all around. And but very weak, only 20 knots at 300 hectopascal, which is more than 8,000 meters, 9,000 meters. The stratification of the atmosphere in 3 layers can be observed, and in which the middle, the central layer, is extremely dry, and the upper one, around 10,000 meters, is practically saturated, which is very important for the future. So this can lead to formation of clouds, and this means we have a denser layer which can oscillate, and we'll see what happens. The temperature were completely wrong. We had never freezing at 6,000 meters. So what happens with SkySight for the 26th of November? I mean reforecasting. So in the north, here we have north westerly flow about 20 knots. San Pedro is here, which increases south to 40 knots, 30 to 40 knots here, with a relatively continuous and much more intense wave systems to the south, the same as shown by Mr. Ezio Sarti. So this is the flying area. Calam is here. So the sounding at the Sairekabur, remember, this was our starting point and finish point every day. So the sounding here at 4 p.m. shows once again a stratified flow, strongly stratified flow in 3 layers. The wind was true, 40 knots at 8,000 meters, but the temperature is totally false. The reality was 10 degrees C higher. The diagram shows a saturation at approximately 200 hectopascal, more or less 12,000 meters, corresponding to the altitude of the pseudo-lenticulars visible in the photo below. So this is the sky seen from 8,000 meters looking to the south above the Sairekabur. In the distance you can see here the Nevada Ojos del Salado volcano, the highest point in Chile, 520 kilometers away. The local topography, if you look down, can hardly justify such a large wave system, so it will be advisable to consider the abrupt step which passes from 2,400 to 4,500 meters in 20 kilometers as being the triggering factor for this hydraulic jump. This is the sky seen from the same location looking north. These clouds are typical of hydraulic jumps because of the formation, no trailing edge, a very fringed leading edge. And these are the conditions that the pilot had to leave at 8,000 meters, 7.6 meters per second, but could not go further because of lack of oxygen. At the end of the day, looking further south, most southerly at 8,000 meters, these pseudo-lenticular clouds, much more to the south, are really typical of a hydraulic jump. You see a fringed leading edge, and the trailing edge is undefined. The satellite photo at the same time clearly shows the presence of the pseudo-lenticulars here along the chain of the volcanoes, followed by a gigantic hydraulic jump, which is in fact a frontogenesis covering all Bolivia and the rainforest, at the beginning of the rainforest in Amazonia. Here is the same sky at the same time seen from the ground in San Pedro de Atacama. The oasis here is visible in the foreground, sorry. It is obvious that this hydraulic jump copies the steep step of this altiplano generated by the stratified flow and the synchronism between the thermal breeze and the geostrophic wind. The wind on the ground here was zero. Now let's take a look at the reforecast of the next day, 27th. We have an extremely dry, when I say extremely, it's out of scale, extremely dry stratified flow in the first 500 meters, 500 hectopascal, and the moisture increases up to the saturation up to 10,000 meters. The wind is westerly at all altitudes, with 10 knots only up to 7,000 meters here, and then 20 knots at 8,000 meters, corresponding to reality. We had an accurate wind measurement system. The temperatures are completely wrong. We could observe 13 degrees, 13, more than the soundings. This day was flown in blue wave all the day. The condensation of the hydraulic jump were very present but too far for us on a completely unlandable terrain, and in any case we were at a maximum safe altitude. We are here at this altitude. The oxygen is not sufficient to be safe, but we couldn't go far, and this is also Bolivia, which is prohibited. But it was not our major concern. So the reforecast from SkySight confirms that the wave system is indeed much more powerful at the second, third, and fourth rebounds, as confirmed by the photo. You can see the cross section here, and probably we could have gone much above 12,000 meters, but we didn't have enough oxygen. From this position, looking south, no cloud formation can be seen. We will fly in blue wave between 5,000 and 8,000 meters the whole day. Observe the difference in altitudes between the altiplano here, 4,500 meters, the volcanoes, almost 6,000, and the Salt Lake here, which is 2,400 meters. And luckily we had an escape, a safety airport here. This is the satellite photo of the same day at the same time, which confirms the total absence of condensation in the flight area and a gigantic hydraulic jump under the frontogenesis, which covers a good part of Bolivia and Brazil. So the reforecast of November 29 shows also possible thermals, but a low gradient up to 7,000, 8,000 meters, a lower stratification than the previous days. The measured temperatures has always been 11 degrees higher than the forecast, but we could fly without problem up to 8,000 meters and even more. So the reforecast analysis shows a strong much stronger second rebound, more than 7 meters per second, and probably more than 12,000 meters top, propagating at least until the tropopause, so maybe above, who knows. So the glider in this position was 8,500 meters in the blue and had to turn back because of the lack of oxygen. On December 1st, the expedition is closed and we haven't done any weather analysis, and so what you see in the future is a reforecasting. We had a farewell party in a restaurant in San Pedro. The STEM S10 had come as a tourist, but it will be a magnificent late afternoon, so we decided to have our ladies flying. So this is the photo we had leaving the restaurant. We have a gigantic hydraulic jump and single conventional rebound waves. So we are at the Sacré-Cœur. My wife is flying. This is the rotor at 6,800 meters downwind of Sacré-Cœur. The wind increased from 12 knots at 6,000 meters up to 32 knots in only 1,000 meters height difference. The rotor is absolutely stable. There is zero turbulence at all. So my wife, who is very cautious, she felt very comfortable in short-sleeved shirts even at 7,000 meters. Oh, sorry. No. The SQT diagram of that day shows a very strong stratification and in an intermediate layer, both in moisture, means density, and wind speed. So the wind speed is the speed is very low, 10 knots up to 500 hectopascal, then 20 knots, then 30 knots, then 50 knots. But the temperature was 10 degrees higher than the sounding all the time. The condensation of the rotors here and of the lenticulars here can be seen. So the actual temperatures are shown here, and as you can see, we were far away from the sounding. So the peculiarities of a tropical gravity wave and jump are that the convergence lift works very well with very weak wind, not even sufficient to make a ridge lift. The jump seems to be triggered by the positive altiplano step, this one, which is reversed respect to what we knew from US and Europe. Is the altiplano creating a supercritical flow, the Froude number higher than 1 just after the step here? In my schema you see that I have put the leading edge of the pseudo-lenticulars just where they were. That means a few kilometers downwind of the line of the volcano. But I don't believe that the volcano themselves can trigger the jump, because they are isolated mountains and conical. As you can see, the hydraulic jump seems to be triggered by this step. This is a modified satellite view of where we flew, and you can see from Calama, San Pedro, and then the range going to Bolivia and then Argentina or Brazil. So would the altitude create a jump? I don't know. Another particularity: the conventional single rebounds show a lift value that increases with the altitude, contrary to the usual US and European situation. Is the positive step generating a compression-induced stability, which in turn helps the oscillation of the air mass? I don't know. Another one. It has not been possible to forecast the presence of rotors, which were free of any turbulence and did not look like rotating rotors, but just like a cumulus. Why? Another peculiarity: the actual temperature were always 11 to 14 degrees higher than the sounding. Why? The compression from the altiplano step, 40% reduction in section, or the overheating due to 250 kilometers traveling over the desert, or both? Then the actual QNH in Calama airport has always been 10 to 14 hectopascal higher than the GSS or the WRF database. Why? Compression or problem with the model, such as the lack of a good initial data, which is unlikely? Were the moisture stratified flows a major factor for the presence of waves and jumps? See the works of Lawrence Army. When I mean moisture, I mean density. You see, we always had a stratified flow with an intermediate denser flow in the middle. And now, organizing another campaign means Bolivian clearance up to level 340, oxygen pressurized briefing, turbocharged self-launcher or tow, securing San Pedro airfield, support from international scientific body, and some money. So more info on my website here, and I thank you for your attention.